Hey folks, what's up? I hope you're all having a good night. I'm gonna do some Odin and WASM over here. It's late, but I've been working really hard, and I just need to take a break. And how do I take a break? How everyone takes a break. They go build video games, right? Solve problems on video games. Isn't that how you all do it? That's how I do it. Anyway. Hey Pierre, good to see you. You're on Twitch. How you doing, Pierre? Quite late. Yep. Quite late. Here. I'm going to I'll do this, I guess. I don't even think that's gonna work, is it? No. There we go. How you doing, Pierre? Good to see you. All right. You're exhausted, but that's to be expected. At this time of night, yeah. Absolutely. All right, I guess I'm just gonna get into it. People will come in. Where did we leave off last time? We figured out a few things. For example, we figured out that libraries is that the right term? Whatever. Things like Scriptin and Odin and in libraries like Mock and Zig, I guess. Maybe a few other ones I can't think of right now. Xdism. Xdism is a good one. They have a bunch of glue for WebAssembly and JavaScript to communicate to each other. What we went over is that WebAssembly is a block of memory, essentially, inside of the browser when it's loaded in. And if I went like memory like that, we can actually go see what's in the memory here. So because WebAssembly is a block of memory, essentially what JavaScript does is it needs to know the location of some value in terms of its memory address, where it lives, and then the length. How far deep into the memory block do you need to read in order to get to read the full extent of whatever value you're trying to read? So you can see there's some values here, and they have addresses, and you can see that. So we figured all that out. We're not using glue. We're not using any cheats. We had to learn this the hard way. The glue that comes with that stuff is an abstraction to make it easy for you to not have to do the things that we're going to be doing. So with that in mind, I've also decided that we're going to change the nature of these arrays. We were originally going to have one big array. It was just going to be one flat array for everything, and then we were just going to add to it here. But I think what I'm going to do instead is I'm going to have an array for each structure type, and that's it. Those are going to be our flat arrays. If we were to ever save the state of the game, we would just take all those flat arrays and save them all as one big one, which we can do inside Odin here, and then we can import it back in if we want to do state stuff. So I'm going to be working on that a bit. That'll make life a lot easier. So yeah, that's kind of what I'm going to plug away on tonight, just because I need something different to do. So I'm going to get through the Twitch ads because Bezos wants his money. Put that up. Yeah. Hey Riz, how's it going? Hope you're doing well. Everybody on the YouTube side, hello. If anybody's on anything else like Rumble or Algora or LinkedIn or whatever, or X, yeah. I'm just waiting for the Twitch ads to go through here. It's 2 minutes and 20 seconds. So yeah, we'll see how far we get tonight in a few hours or less. Then I'll rest my head on my pillow. Get back to it in the morning. 2 minutes of ads. So annoying. So annoying. And you know, it's like the ads don't even give you that much money. Like poor Twitch peasants having to watch the ads. Like peasants. For what? So I can make like $2. That's the value of your eyeballs on Twitch. You Twitch peasants. It's $2. How does it feel having such cheap eyeballs? A minute and 15 seconds. Also, my text for the Twitch ads it's really hokey. I'm not good at art, you know, or anything creative for that matter, so I just dump text on screen and go for it. If you've been watching the Zig version of this game, you'll know that I don't have an artistic bone in my body. C'est la vie. There's 37 seconds. And for each second that plays, Bezos wipes his bum with another $100 bill. He just has $100 bills to wipe his bum with. That's it. That's what they're there for. $100 bills for bum wiping. Five seconds. All right. Done. All right, so the deal here is that we're going to break this up into a few arrays. I think so far what we can do is we can get rid of these notes. We're going to have ships, which we know are only going to store these two values right now. We're going to have a map, which is just what would you call it? A capsule for the cell data. Each map has X number of layers. The reason why is because each layer might be a type of layer for the map. And so one thing that we might do is we might have a background layer that points to a single asset. Doesn't matter what the asset is on the Odin WASM side. WASM doesn't care. You just render whatever asset you want. But then what you would do is for each coordinate in the map, normally you'd fill in a value. This coordinate has this value. But for a background layer, for example, you just need the asset, and then you don't have to fill in anything else. You could just be an assumption that the background layer will take the full width and height of the map, even though we don't explicitly define the width and each cell in the layer. So that's why we're storing type here. We're going to be able to tell how we want to treat each layer. So then we can start creating some arrays. So it would be something along the lines of game ships array. We could be pretty verbose, I suppose, even though I don't really think that's super verbose. But and so then our ID, it would be 1, and then health points could be 10. And we would just continue to, essentially we just another 10, 30 hit points, just for a little bit of variety. And yeah, let's do 5 because I think that's what we had in the Zig version. Now in our maps array, we're going to have a map that's going to be, we'll go 16 by 16, and that'll be that. We're going to start with one map. And the reason why we're starting with one map is it's a lot simpler to kind of wrap our heads around, because there's going to be a lot of complexity that's added to the map, as we're about to see. And then we're going to have game layers array. And so then our layer will be layer 1, map ID 1, right? And then type, we'll have to create an enum. So to do enum here, so that I don't forget to do it. So then we'll go layer types, layer type, I guess. Enum 16. And we're going to do something like background, foreground, entities, could be, ports, whatever it is. Player, maybe, just for the actual player is. Do I need anything else? I don't think I need anything else right now, so that's fine. So then what we can do is we'll go layer type. I wonder if you can just do this. We're going to give this a shot. Layer type background, and we're going to turn this into a U16 value and see what happens here. So normally then what I would do is I would start filling in the 16 by 16 values. Right? So it'd be 1, 2, 3, 4, 5, 6, 7, 8. What? Okay, so there's 16, and then I do this 16 times. Okay, so I could do this, but I don't really need to do it. I'll just comment it out for now because I'm sure we're going to use it to just as a dumb way to get this working. Because I know that this layer is a background, then all I really need to do is just have one value, which just points to the asset that I want to point to. And even that I don't technically need, but I'm going to have an empty value in here anyways. So for example, let's say that I do want to point this to a specific asset. I would put a number right here that would point to that is like it means something to whoever is rendering the game. Doesn't mean anything to us here. The number could be anything, but it means something to the person rendering the game. And in some cases, we're going to want to set that number so that the person rendering the game knows which asset to use. Sometimes it's just by nature of this being the background layer 1 of map 1. You don't even need to know. You just do it. You just render whatever you're going to render. But just in case, we're going to always make sure that there's at least one value here. And we'll have to do checks and stuff when we're dealing with the arrays. We're going to have to check and make sure that this exists. Now, the other layer we can add on top of this now to map 1. So the layer here could be something like, sure, let's go player. Now, in this layer, we can do one of two things again. So we can, again, initialize 16 by 16 values, or whatever the size of this array is, of this map, and just put like a 1 wherever the player is, and then just update that. The other way we could do it is, because we know it's a player layer type, we can treat it again as kind of like the background layer. It's a special type of layer, and so we can just have 2 values, which is just the X and Y of where the player is in this layer, and that will position them in the map based on, it'll be like an initial position, and then what you can do is update that position, or keep track of the player in another array, you know, things like that. We can tweak it as we go along. For entities, this is where it starts to get wonky. So let's say that we have a player, and then we also have 5 ships, right? Now, maybe ship 1 is the player. We'll get to that at some point. We haven't defined the idea that a player is an entity. It's fine. We'll get there. Let's not worry about it for now. But if we have 5 ships, then we need to know which entity goes into which coordinate. And I think in this case, we would need to do something like this, where we define 16 by 16. And then in that case, the value of any coordinate here would reference one of the ships in the array. So it might be like 1, 2, 3, 4, 5. And then things that you can do, you'd have to do this again for port or ports. So for example, in the game, wherever you might have a designated port where you'd go from traveling in the ocean to landing on a port, going into town, you'd have to do exactly the same thing here. So you'd go, I'll just pseudocode it, ports. This will be 3. No, sorry, this will be 3, and this will be 4. You can already start to see the problem here, right? And then yeah, you'd have to essentially like define it. And then the same thing goes for things like if you just have extra layers. So for example, it could be background, foreground, anything, something along those lines, or like general, maybe. Yeah, maybe anything. So what you would do is, let's say that you wanted to like, you have a background layer, which is maybe grass or the ocean or something. Then you have another layer on top of that, which includes trees, right? And so if you think about it in a 2D world, you're going to want to put the trees over top of whatever your background layer is. So now you're talking about another layer that's like, this, anything. And again, you're going to put numbers here, and it's going to represent an asset, like what belongs in this coordinate of the layer. And the numbers could mean anything again. Doesn't matter what it means to the WASM Odin side. But for the rendering mechanism, which is going to be our browser and JavaScript, we're going to convert that into like, a tree or whatever the case is. Yeah, so you can already see the problem. This is going to be annoying to manage, especially if you have large worlds where maybe it's like 100 by 100, which it might be that might be what happens with this game. We might have maps that are the size like hundreds of hundreds, and it gets pretty crazy pretty fast. So at some point I'm going to have to resolve that issue, but I need to resolve it in such a way where it still rides that balance between efficiency, because flat arrays like this are very efficient in terms of managing structures, performing operations on them. CPUs really love caching flat arrays like this. It's just like an extra bit of performance boost out of an already performant thing inside of WASM, because it's WASM is like more low level than JavaScript essentially. So I'm going to have to think about that. I might have to do something like add some functions that let me generate this data, pre-allocate the array size to begin with and zero everything out, but then set the data and do things like create layer 1 of type with, of a value. Plus that would actually make it nicer, because like a function like, let's just pseudocode it out, right? So it would be something like this. It'd be create game layer, let's say. And so your game layer, you wouldn't need the ID. You could auto increment the ID, map ID, right? You'd have layer type, right? And then you would have asset integer. It's just a number. And then you could just say like return true if it worked. So the idea here would be that you'd go whatever your offset is in terms of layers. So you'd have to determine offset. That's a whole other problem that we're going to have to solve soon. How do you determine offset? Because you can see as you add chunks, right, your index of where you're going to append to the next one changes, even if you have a statically defined array size. Like, this does an inference, but essentially it's just infer the size based on what you've entered in here. But if we're going to use these kinds of functions, then we're going to have to set the size ourselves in order to keep things efficient. So given that, we're going to have to figure out how things got placed and when the next available spot is for a layer. And that's going to vary depending on what goes in here, right? So if it's a background layer, then you've only got 4 spaces originally taken up. But once you hit something like an entity layer, you're going to need to know that it's going to take up the amount of spaces the map width and height does. So this is going to get fun. But essentially you do that, and then for if layer type is equal to entities, right? So now what you can do is just zero it out. So append to game layers array with ID, map ID, we'll add auto increment for now. We'll just assume it's auto increment. Map ID and layer type plus map width times map height zeros. Right, so you'd create the game layer, and then when you're setting up the game, initially, like within the code base, I mean, you wouldn't do this, what I'm doing right now. What you do, it's like create game layer, and then you'd pass in some values, whatever it is, and then you can go set value of some array index, and then it would be game layers array. No, it wouldn't be this. No, it would be set value of layer coordinate, and then you'd pass layer ID, whatever it is, and you'd pass X, and you'd pass Y, and you'd pass a value, and then it would set whatever this is. And that way you still have a predefined block of space that's nice and flat. You still have a way to create all your initial data here without having to do this weird stuff, and you have a nice way to reach into the arrays and set their values, so that if you decide to make changes down the road, or if you want to make changes on the fly, you can do it. You can do it all through these functions. And so you still get the benefit of the flat arrays. That means that we probably don't need that. Specific ship would just have to be like return game ships array ship ID times ship enum length. I think it would be what, U16 ship dot length. Oops, what did I do? It's something like this. You can get the length of the enum here, and so it would be 2, and then you would just go into your ships array and offset it. Whatever your ID is, you would assume that that's the index it's in. The other thing you could do is you can just go for I less than game ships array length plus I. This is all pseudocode. And then somewhere in here, if game ships array 0 is equal to ship ID. Well, there you go, right? And then over here, you instead of I, you'd go I plus equals whatever it is up here. So you're just iterating through the array until you find the right ID. And the reason why you might want to do this is because your IDs might not be inserted in order. So at index 0, you might have the ship ID 2, and then in index, let's count it out. So if it's 2 values per ship, so 0 would be ID, 1 would be HP, 2 would be another ID, and so at index 2, your ship ID might be 5. And so that's why you can't, you might not want to count on the index offset. You might want to actually go and search for the ship in question by going through the array. Yeah, and you could even just do this, right? That's pretty much it. That is pretty much the pseudocode for it. And so then you would do the same thing with maps and layers. Another thing that you're going to want to do is you're here. Let me move these down. Let me just try and organize this just a little bit more. Is it code Odin and WASM to the night day? Must be a full moon. I've been working really hard and I just wanted to do something fun for a few hours and yeah. So how you doing, Dojo? Good to see you, man. Saw you earlier on Ginger Bill's stream. He kind of inspired me too. I was watching him. Was kind of inspiring and I'm like, man, I have so much work to do and I got through some of it, feel good about it. So I'm like, okay, I'll just take a break and do this for a little bit. Get some stuff sorted out. It's a bit fun. All right. So now that we have kind of the idea of how we're going to get into these arrays and what we're going to set up, we also need to do something about our getting, I guess okay. First things first, we got to get values, right? So we're going to have to do something like get ship HP. Okay, and then it's going to be like that. All right. So we're going to essentially copy whatever we're doing and get specific ship. We're going to figure that out. We're going to copy it over here and then we're going to return an array index that matches the enum index. So in this case, it'd be I from here. Maybe let's just try and pseudocode it a little bit. It'd be return I plus 1, I believe. Yeah, because it'd be like ship dot. It'd be u16 ship dot HP. That's what it would be. And because HP is in here, it's in position 1 of the index, and so that's about right. Yeah. So I would reference the ID, but ship HP would reference +1. So there we go. So we kind of have it pseudocoded out. So then you'd have to do exactly the same thing. All these functions would have to exist for maps. All these functions would have to exist for layers. And once you have that down, then what you can do is you can take actually player HP equals PHP. Yeah. Yeah. How you doing, Quad? Good to see you. Then what you can do is something like get layer coordinate value. Actually, let's get value of layer coordinate, and it'd be layer ID X, Y, and it would just return U16. That one should be pretty easy because of what we'd have to do is go if layer type is not equal to one of the packed layers, then reach into coordinates. Right? Otherwise, this just won't work because if we have something like a player, that's not going to work, right? We're going to have specific functions for this kind of stuff. So we'll deal with that too. Then you're going to also want things like get map of layer, right? And then you're going to want to reach into first you get the layer, so it'd be like get specific layer, or maybe like yeah, I guess get specific, something along these lines. You get the specific layer from the array, and then you'd go layer map ID. So your offset would be I plus layer map ID, and you just return that. And that gives you your map ID, and then you can go get the map. and essentially return that. So this is actually all one function, but that's kind of how we're going to do it. You just reach into the layer, get the map, return map ID. We'll sort that out. And we could do, we could get a little bit crazy. We can do things like get map layers. Right, and so you just go for I in game layers array, where the is equal to whatever your map ID is searching for, and then it would just like return layers. Because it's WASM, we can't actually return all the layers. All we can do is return, we could return like total layers, something like that. Get map total layers, and then we'd know how many layers are in the map. We could do another one where if we do get the map layers, there's something that we can try that's a little bit of a trick, but the data should be small enough that I don't think it's going to be a performance issue. I'll explain in a second here. Had to get a sneeze in there. So the idea would be that you'd go through the layers array, match up the map ID to the map ID you're searching for. And then what you would do is you'd create a new array right inside WASM. And I already see that's not going to work. You cannot create a new array right inside WASM. Not within a function like that. Maybe you can, but the issue that you're going to run into is how you're going to reference this array, this newly created array that's created on demand, and its size is dynamic. You can't determine. Actually, you can determine in advance. What am I talking about? Okay, you don't have to do anything dynamic here at all. Okay, so as part of... Yeah. Okay, so as part of initialization, so maybe you'd have an initialization function. Then you can iterate through the game layers array and get the total count of layers per map plus their layer IDs, and then you'd store each map's layer data in an array. And then you can just reference that array block. So we just have to set aside some kind of array data and kind of like process it through an initialization function. Another way to do it is manually keep it. That's really annoying though. Every time that I do like a ship or layer or whatever, I'd have to go make sure that there's like a game map layers data array, and I would have to do something like map ID 1 total layers, I don't know, like 4, right? And then the IDs, and be like 1 2 3 4, right? And then I'd have to keep doing it. If I was really smart, if I was super duper smart, if I was super genius, if I was an Omega GigaChad developer, what I would actually do is instead of having to track this individually or on initialization, so this would be an alternative method. When you use something like create game layer, which I'm going to have to do to initialize this data, right? Which is what we discussed on the outset. Then you would update game map layers data array inside that function, right? So as we generate the surrounding data, we just automatically determine that we should also update this data. And what that does is it allows us to reference the starting memory address of this data and the length of it in JavaScript, and then we can just pull this data out. The only downside to this is that this can't be inferred. It would have to be, we'd have to set like a nice big block of data in advance and just use it up as best we can. If we do dynamic data, I worry that it can be ripe for issues and overflow, and we wouldn't catch it. So I would lean towards setting it like a big number, like whatever, and then whatever it is. That would probably work. So I'm just gonna make a note of that. Game map. Hey Shreyas, how you doing, man? Good to see you. Good to see you. I'm doing all right, thanks. Set. It's like a preset size for the array. Overflow? Nah, it'll be fine, right? It'll be fine. Overflow's never harmed anybody, right? It's never harmed a soul. Not one living soul. All right. Yeah. So, I mean, generally speaking, that's really all we need to start with. We're smarter than that. I don't know about that, Shreyas. I know who you're talking to. Speak for yourself, Shreyas. Just put some diatomaceous earth around the outside of the server. Bug proof. Perfect. I think that's a perfect idea. When your pet gets like when you're filing down your pet's nails or you're clipping them, sometimes it just happens. You clip just a little bit too much, and they bleed a little bit, and then you dip the nail in diatomaceous earth because it stops the bleeding quite fast. It works really well. It's like that. We overflow just a little bit too much. We clip just a little too much, and then we'll just diatomaceous it. We'll be fine. We're definitely smarter. All right. If you say so, Shreyas, I'll accept it. I'm not going to argue with you. Okay. There's something else that I need to take into consideration now, which is on the Zig version of the game, we had it so that we could set the viewport, and the viewport is really just any rendering mechanism is going to determine what its own viewport size is based on like screen size, things like that, right? It's like a front end rendering issue. So if you think about it from a web perspective, that's the dimensions on the website. On a mobile app, it's the dimensions of your phone, whatever it is. The reason why we would want to set viewport is because we want this WASM, this Odin WASM code to essentially tell us what we should display. Okay, that's what we should be getting out of this, out of the viewport. And so what you would do is, let's say that you have a 4x4. Well, hang on. Let me make it a little bit bigger, I guess. Let's say, nah, you know what? Let's go 4x4. Okay. So we're going to do like a 4x4. Oh man. 4x4 world. Okay. So let's say that our viewport is actually like 2x2, which means that initially we're going to have something like this. Forget the stupid, hang on, too much overflow sounds like a girl math recipe for a free small slush. Too much overflow. Like, I totally want that slushy. Okay. Oh my God. Oh, you have no idea. Too much overflow, girl. Get it? For 99% of cases, overflow shouldn't matter. It matters to me, Shreyas. It matters to me. 100% success speed run first try. Like if you use 64-bit values, you basically have infinite. I mean, yeah, for the most part. Yeah. I'm talking about array sizes, which are a little bit different. But it's okay. It's okay. We'll be fine. So yeah, if you have a 2x2 viewport, it means that you can only ever show 2x2 of a 4x4 map. So what you're going to want to do is have the viewport essentially, I guess it would have to be like another viewport function to tell me what I should display in viewport coordinates XY. So viewport coordinates XY, for example, would be like 0, right? So let's just, unlike other tech streamers, I don't treat you like children and bring up stupid little crayons and blackboards. Okay. You're all grown adults, right? And then you'd have, I hate when other streamers do that. It's so condescending. Okay, so you have a world, like a map, right? That's, oh, come on. A map that's this size, but your viewport is much smaller. So what you're going to need to do is you're going to need to tell the viewport that it has to overlay the map. It's got to stack it over top of the viewport. And it'll start first by this, right? It's going to do these two, right? That's where we're going to start. But what's going to happen is as the character moves to the edge of the viewport, then the viewport is going to have to change the coordinates that it is using on the map, and it's going to have to move them over here like that, right? And so then once you go right by 1, then your 2x2 viewport is these two and these two. And then you can imagine the same thing if you were to move down, and it's going to go like that, right? So your viewport is smacked right over top. And so that way what we can do is anything that renders this map and this viewport, given any viewport size, WebAssembly will calculate for you, and it'll just flatten the entire map with all its layers. And so then essentially what you're going to be able to do is just call like what is in XY viewport layer, I don't know, Z, right? And it's just going to pierce through the layers on the map, and it understands where it is, where the viewport is in relation to the map, and then tell you, here's, you know, what it is. Then you could imagine, let's say, over efficiency is inefficient. Sorry I'm disturbing you, but can you explain to me what you're doing? I'm just building the same game I was building before, Shreyas. Just in Odin instead of Zig. Really? So now imagine that you have a viewport that is bigger than the map. And if you have a viewport that's bigger than the map, then the entire map fits inside the viewport plus, right? And so then what do you do? Well, then you could do something like what we had in the Zig version of the game, where if it's big enough, that's what she said. Oh yeah. If it's big enough, then you can add padding. And the WebAssembly code can tell you what that padding is. And so everything that I put in, well, let's go with like you, right? So all this would be calculated as padding. Right. And so then, so imagine that I do it. Well, let's just do it all here. Okay. I'll go through the trouble of doing it all. Oops. Okay. And so the map itself would just fit in the center right in here. And anytime that your rendering engine asks what's in viewport coordinate 0, 0, WebAssembly would just say nothing, it's empty. Right? It's just empty. So just don't render this. And then what's in this coordinate? It's a map. Maybe the map doesn't have anything. Maybe the current layer that you're looking at doesn't have anything either. And so there would be a special value that would mean that there's like nothing processable in the padding. Right, and then you'd have regular values for anywhere the map is, and so right away you can see that WebAssembly can take care of manipulating the rendering mechanism, but in a way that's portable to any rendering mechanism that would render a 2D game. It just fits within the confines of whatever you're rendering. And does padding and whatnot for you and centering. And then if you don't want it to be centered, we can add functionality so that it's not centered, so that it's top left or whatever, always top left or whatever it is. Gonna start working on the map hacks. WASM is getting abused. It'll be a target for emulators soon. I think there are WASM emulators. Yeah, I'm pretty sure there are. If only you could use multiple cursors. Yeah. There's an x86 emulator in WASM. Yeah, there you go. I think I've seen them in the wild, yeah. Pretty sure. Yeah, so that's kind of the idea behind the viewport functionality, which we're going to have to include and create here. So we need to have a way to it would have to be like load map, I guess, into viewport. That might be a little bit too verbose. It might just be load map, but let's just say it's load map into viewport, and so you'd pass in a map ID, and then it would just handle all of the above, right? And then you'd have to have like a viewport array, which is allocated based on like a set viewport size function, right? And so then it would just it would always update this array inside load map into viewport. And then anytime you needed to do operations with the viewport data, it would always be in here. And so then when you did something like get value of I don't know, viewport at coordinate by layer. I don't know. So it's crazy, but you know, whatever. Be X, Y, and then like a layer ID. And if X, Y is not padding, reach into map layer, get value, return. Otherwise, return special padding value so that the viewport knows that, so that the rendering engine knows that WASM is telling it, hey, this is just like a padding space. Just don't worry about this. I think another thing we had in the Zig one was when you do for set viewport size, if you update the viewport, like if you're going to do it on mobile and you flip from landscape to portrait mode, you can update the viewport, and then you'd have to recalc the grid, recalc the viewport and map essentially. Yeah. Yeah. Okay. So WASM can do anything as long as you don't have to interface with the outside world, which is also getting better. Yeah, isn't the WASI stuff coming out soon? Or it's not out soon. It already is out. But the like WASI implementations will let you do like you can reach into like a file sandbox, I believe. I'm pretty sure there's somebody already using that kind of functionality. It's pretty dope. Yeah. Okay. Okay. Yeah. Yeah. WASI is nice, but too many rough edges. Yeah. Yeah, it's got its work cut out for it. It's early, that's for sure. Okay, I think we have a solid plan. That's all I really have time for today. I wasn't really gonna go for very long. It's I guess I've been streaming for an hour. It's probably a good time. I'm tired too. I just wanted to plan out some things and shoot the breeze and have a bit of fun. But there's a plan here. I might work on some of this off stream so that by the next time I get on, some of this is just done, because it's pretty obvious what we're going to do with some of this. And then we can just get to rendering it again on the JavaScript side here, plopping it down, playing around with it, putting the ships back on, attacking each other. We'll get there fast, I think. So we'll do all that. But yeah. That's it. That's all I got. I'm done. I don't even have enough viewers to like raid out. Whatever. I'll end the stream. Nobody will mind at this late hour with such few viewers. Okay, that's it. I'm gonna call it a night. I'm gonna get some sleep. I don't know when I'm gonna stream again. I am hoping I will stream again tomorrow and do more of this. It just depends on what I get done. But I'll try and get back on soon. This week at some point I want to get back on. I think the weekend will be my jam. But we'll see. We'll see what happens. Okay. I'm out of here. I'm tired, guys. But that was fun. I needed that. I appreciate it. Okay, have a good night. Have a good day. Wherever you are, whatever you're doing. I will hopefully see you all soon. Take care, everyone.